Hi everyone. Today we'll be discussing how to construct a quadrilateral when four sides and a diagonal are given. But before that, let's try to understand what information is really needed to construct a unique quadrilateral. So before we talk about quadrilaterals, let's take an example of t-shirt. So suppose you got a great t-shirt and your friend comes and asks you for the details of the t-shirt. So there's two things that you have to tell. One, that I got a medium t-shirt. But with this information alone, your friend can't get the same t-shirt. Your friend also needs to know the style. So the shape of the t-shirt, whether it's a V-neck or it's a turtleneck, which type of t-shirt it is. And same in quadrilaterals, we also have to specify two things. One is the size, which is given by the dimensions of the quadrilaterals. And the dimensions are the sides of quadrilateral. And the other thing is shape, which is given by the structure of the quadrilateral and shown by diagonals and angles. Alright. Now let's understand with an example what will happen if I only give one of these parameters and not the second. So suppose we have an example where it's written to construct a quadrilateral with sides 2 cm, 3 cm, 6 cm and 9 cm. And we can make a quadrilateral like this. But another person can argue that if I bend this quadrilateral a bit from the middle, like this, it will still have the same dimensions, it will still have the same size, but it will be a different shape, so it will be a different quadrilateral. So we can construct a unique quadrilateral only knowing the size or the dimensions of the quadrilateral. We also need to have an idea of what shape the quadrilateral is going to be. Now suppose looking at this example, if we had something in the middle that keeps the structure intact, then we could have said that this is the right information to construct this unique quadrilateral. So let's think about that. Suppose we fix a diagonal in between, and you can think of diagonal as a strong rod that is placed in between which keeps the structure intact. So it can't go below like this and it can't go above like this, and it keeps the structure intact, which means that the shape stays fixed. And also because we have given the dimensions are also fixed. And now since the size and the shape both stays fixed, we can say that four sides and a diagonal would only give one unique quadrilateral, and that is this. So when we have both this information, we can say we can construct this quadrilateral. Otherwise, if we only had four sides, we could have constructed many quadrilaterals of the same dimensions. Now let's look at other such conditions that can be possible. So the main problem was that the shape was not staying fixed. We gave the dimensions to keep it fixed, but the shape was not fixed. So we placed a diagonal in between. Now what if instead of diagonal, we just use the angles and we keep the angles between the sides fixed? Even that should work. So if the angles are also fixed and the dimensions are given, then we can say the shape stays fixed because it can't now go below or go above, it can't bend because the angles in between are fixed. And the size we know is already fixed because the dimensions are fixed. But not just this, we don't even need to know the length of four sides. Maybe we can also do with only three sides. So if we had three sides known and the angles in between known, can we think of any other way that this side will go except this side, that it was already there? So if we make this side something like this, it can't happen because this angle is fixed and even this angle is fixed. So the only way this side will happen would be to give this quadrilateral only. So even three sides and angles are the right condition to uniquely construct a quadrilateral. Let's look at another condition. So earlier we replaced diagonal with angles. Now from three sides, can we also use diagonal instead of the angles? So let's keep a diagonal here. And you can say, again by the same argument, this is the only side that can happen. But that is not true, because another one can argue that we can bend this side like this and make another quadrilateral like this. And you can clearly see this is very different from the quadrilateral we just saw. And that is because this diagonal is only fixing the configuration of these two ends. We also need something to fix the configuration of these two ends. So instead of one diagonal, if we take another diagonal also, we take two diagonals. So this keeps configuration of these 2 points fixed, and this diagonal keeps configuration of these 2 points fixed, and the dimensions are already known. Then we can't bend around anywhere and we can't make any other quadrilateral. So even this would be a unique condition to define a quadrilateral. So 3 sides and 2 diagonals also works. And in general, it's good practice if you sit down and manually construct what works and what doesn't. But as a general rule, we can see that if a quadrilateral has 4 sides, 4 angles and 2 diagonals, which is total of 10 measurements, then if we have at least 5 measurements, then we can uniquely construct a quadrilateral. As you can see, 3 sides and 2 diagonals gives us 5 measurements. 4 sides and 1 diagonal also give us 5 measurements. So now let's look at each of these conditions one by one using examples and how to construct it now that we know this information. So let's look at the first condition. How to construct a quadrilateral when 4 sides and a diagonal are given. And let's take an example. Say the quadrilateral sides and diagonal is PQ given as 5.5 cm, QR is 5 cm, RS is 7 cm, PS is 4.2 cm, and QS, which is the diagonal, is 6.1 cm. So PQ, let's start with PQ. It can be something like this, 5.5 cm. Then we can get QR like this, which is 5 cm. Then we can have RS, which is 7 cm, and PS, which is 4.2 cm. Then we can connect Q and S to give us the diagonal 6.1 cm. Now this is what a rough sketch of the quadrilateral should look like. Now we need to think what the approach can be to construct this quadrilateral. So we don't know explicitly how to construct a quadrilateral, but what we do know is how to construct a triangle when 3 sides are given. So our idea can be, if this quadrilateral I can split in 2 triangles, both of which whose sides are given, then we can make 2 triangles and say that the combination of this is this quadrilateral. And let's try to figure out those 2 triangles. So one triangle can be this, using this base, this side and this diagonal, alright. And we can get also another triangle here. So if we put diagonal as the base and the other sides forming the triangles, then we can get 2 different triangles. And we can say we can merge both of them to give this quadrilateral. So that is our approach, and let's see it in action. Let's keep this figure somewhere. Let's have our infograph here and let's get started. So first, we'll construct a diagonal as base using pencil and scale. So we'll take the diagonal as base, so which is 6.1 centimeter. We'll get a pencil and scale out, so that's 6.1 centimeter. So this diagonal is made, and this is the base for both the triangles. And as you can see in our rough sketch, this side is already constructed. This is the diagonal. So the next step would be draw an arc of length of one side from its respective vertex using compass. So we can take any triangle to construct first. Let's take this triangle. And how to construct this triangle is what it's written, that we have to take the arc of length of one side from its respective vertex using compass. So let's take this side RS and let's try to construct it. So that's 7 centimeter. So our compass, we keep it fixed at 7 centimeter. And then we put it at the vertex S to cut an arc here. So this length stays fixed at 7 centimeter. Then we do the same thing for this side. So that's QR, which is 5 centimeter. So we have our compass fixed at 5 centimeter. We keep it at the vertex Q and cut this arc. So even this side gets fixed at 5 centimeter. So the intersection of both these sides would give us the vertex R. So this is the vertex R. And now all we need to do is join this intersection point to the vertices. So connect the intersection point to the vertices to get the sides. So this is one side, which you can see is here, and this is 7 centimeter. And then this is the another side, which is this side. And you can see this is 5 centimeter because we get the compass fixed at each of this length. Now it must be pretty clear what our approach is and how we are able to construct the whole quadrilateral one by one. And now we have to do the same thing for the bottom triangle or for this triangle. So let's do the same thing. First, let's take 4.2 centimeter. We'll first construct this side. So that's keeping our compass fixed at 4.2 centimeter. And then from this vertex, we cut an arc. And then let's keep our compass fixed at 5.5 centimeter, which is this side. And then cut an arc from this vertex to the previous arc such that there is an intersection point. And this intersection point is going to be the point P, as you can see from the rough figure. Then all you need to do is again join this intersection point or join this vertex with the remaining vertices to get the sides. So that's one side, and as you can see, this side is done and this is another side. So this side is also made. This side was fixed at 5.5 centimeter, which you can see, and this side the compass was fixed at 4.2 centimeter, so that is also that you can clearly see. And that is it. And that is our quadrilateral. The only difference between these two quadrilaterals is it is rotated because we took the diagonal as base and they took the diagonal in this way. But that's about it. So that's how you construct a quadrilateral when 4 sides and 1 diagonal is given. That's all for today. Thank you.